Today I've got an interesting one. It's just an old electromechanical 7-segment display. So one type I haven't seen before, and one that people don't seem to know an awful lot about. This is made by Fujitsu, Fujitsu Kaiden, which I think is a city in Japan. It's got KK3128B/6, and then a few other numbers on there. And then I don't know if it's a circuit board number, KP6194B, I think that is. It's got these little electromechanical segments here which flip between black and orange colour. So obviously mimics like an LED lit up or something like that. It's got quite a bright fluorescent orange there. Unfortunately some of the segments are missing. This was only basically salvaged out of the e-waste. Just as a novelty, because I've never seen one before. It's got a HD 7447 chip, which is just HD is Hitachi, but it's a 7447 typical TTL chip, which is a BCD or binary coded decimal to 7-segment converter chip. These, or decoder I guess they'd call them. These like got 4 binary inputs, which I think is just a normal binary. 0001 is 1 and so on, and that's converted into obviously the segments needed on a 7-segment display. They're normally used to drive, I think, a common anode LED display. I think these all go to ground rather than high. It's also got a couple of 12-volt regulators on here. These 2 chips, these are actually NEC 14312s, which I think is equivalent of like a 7812 positive 1 amp 12-volt regulator, a couple of filter caps around them. And it's got these other chips, MB434s, which it's got a little F symbol there. I'm not sure if that's a Fairchild or maybe Fujitsu itself, and I think those codes 8006 is the year and the month, so around 1980 possibly. There's also these Hitachi chips, HD 75452Ps, which I think they're actually like a NAND gate input, then buffer transistor, something like that, which makes sense because this is electromechanical. So I mean, that chip runs off a 5-volt rail being TTL, and I think all these other chips are wired up to the same thing, so it looks like there's like one of these pads on this board which has an awful lot of connectors, but I don't think most of them are used for anything. Like you can see, quite a few of them joined together there. But I think this needed 5 volts in to run the chips, and then obviously more around the 15 volts or whatever it takes to get enough higher voltage that overcomes the voltage drop in these 12-volt regulators. They usually need a couple of volts above their output, and I assume they run into these little coils here which do the actual flipping of the segments. Now I've had a bit of a play with this because it took me a little while to work out exactly how they work, because yeah, they're a bit of a strange setup, but it turns out, as I suspected, you can see there's 3 wires, these go into each segment. If I measure these, it's actually a center tap coil, as you'd expect. If there's a coil to get a magnetic field up, normally they just have 2 wires, but in this case we've got 3. So first thing I assumed was it's going to be center tapped, magnetic field one way to flip it one way and the other way to flip it the other. So if we go across the outer wires, which is this blue and white, get 97 ohms. If we go to this grey wire, which I already found out is the center tap, get about 40 ohms to each, 49, 47. So that's the center tap coil there, and we've got all these various diodes and stuff driving into this. Now the other interesting thing is with these chips is, it turns out this actually needs a voltage, so you'd either have that, depending whether you want a positive or a negative, you'd have that center tap either on the positive rail, the 12 volts, or you could have it on ground and then put 12 volts into these 2, or you could have that on 12 volts and then ground either of these 2. Either way, one way you're going to get a magnetic field, say a north pole, and the other way you're going to go south, so you're going to get the magnetic field in opposite directions. So these other chips must buffer between that 7447, which I believe has like a high outputs for LED off, or LED segment off, and low outputs for LED segment on. But these are actually got two coils, so normally a light, obviously you put a voltage into it, or if it's a common anode you ground one side of it and the LED comes on, and then in the other state the LED's off. Whereas this doesn't have a return, so you've got to actually put a voltage in to get one state, to get the black, and put the voltage in to get an orange. So we need a bit of buffering, because obviously we've got to turn, like a low output on here can flick one of them, but when that output goes high we've actually got to put a pulse into the other side of this coil, another high or another low, whichever way we're doing it. So these buffer chips must actually give it a, when that changes from low back up to high, it must actually flick the segment back again. So it's a little bit more complicated in that sense than just having a light. But I'll take this front bit off. There's only one part of that still attached anyway. The other mount's broken off, so it's had a bit of a rough life. Someone's probably dropped it and broke the mount off this and lost the segments. They've all gone flying and didn't put them back in there. So these are this is a display the inside of it. So I've got these little rotating segments here. At the moment they're all going back to black, and we've got these little round pieces here. There's a little central piece which is our magnetic pole. This outer bit's actually magnetic metal. It's got like a plastic around it because that's where the coil, that's basically the end of the coil former. So there's wire wrapped around that going back down in. Then there's two little stainless steel bits welded on just to hold the pivots for the segments. Segment also has this little flat piece on it which basically just stops it, so it bangs against the inside of this, stops it going any further. When it's spun, it'll spin round and it'll flip up and bang into the side of the front fascia bit with a figure 8 cut out of it. And yeah, that was the main thing with that. These little things come out. So I had a bit of fun playing with these originally because I wasn't sure, I had no idea how they worked, because when you put these in here they always flip back to the black when I got this thing. But you put them down, there's no special weighting in them or anything like that. But I did find with a magnetic screwdriver it will attract on one side and repel on the other. So I can flip that so it goes orange, and it'll tend to roll, if I can get it to roll without attracting to it, but it'll tend to roll in the direction of that. Or if it's the wrong way up, it'll flip back over. And we can sort of get that to follow this magnetic field. So there's obviously a magnet in there. It's just two pieces of plastic, an orange and a black one, with obviously a magnet in there. These bits here, this is a magnetised screwdriver. It'll pick up a screw. I can feel that outer bit is some sort of iron. But interestingly, I don't really get a response on that inner bit. But I think I did find that these would stick to the inner bit after I'd used it. But the other ones are a bit weak. I'll see if I can get that. Yeah, it doesn't want to do it at the moment. There's a magnet in this thing is actually pretty weak because it generally doesn't want to pick anything up. I've probably had some iron filings or something that might stick to it, but even those don't seem to, it doesn't seem to collect any rubbish like off the bench here and stuff. I would have thought there'd be a few little bits of metal there. So yeah, if I rotate that, it always flips back to the state. But interestingly, these little coils, I can actually take one out. They actually hold whatever magnetic state they last had in them. Was the thing that took me a little while to work out how they worked. So these, you just got to give them a pulse into each coil and it'll hold the state that it was in. That was the interesting thing to me, because there's no mechanical way of locking these things in place. Oops, there goes the thing. So this is one of these segments removed. You can see the side of it, so it's basically just, I did undo the nut and it just allows this little central piece of metal to come out. It's just a pin basically, but I couldn't get the coil out, at least on this one. It was fairly tightly jammed in there, but you can see that in between these there's another little black plastic bit you can see through the hole there. So it's just like a bobbin thing with, you can see the yellow wire around it, so it's obviously got a fine copper wire wrapped around that. Just a normal electromagnet, except that it's centre tapped. And this little thing sits on here. And I can actually demonstrate it off the unit, I guess. If we connect, say, negative to the grey wire, the centre tap, it's a matter of finding. I'm just on 6 volts on the power supply, I think. That does nothing, and that flips it orange. So interestingly, that magnetic piece in the middle, that little pin up the middle of this thing, just holds its magnetism. I don't know when this unit was last switched on anywhere. It might have been recently, or it could have been years and years ago, but it just holds its magnetic state. So now if I try and flip this around the other way, it always goes back to the orange. Now we've got this other segment here, which if I put it, I can take this one, this is on black at the moment, well, it's fallen out. So if I flip that, it goes orange, but it always pulls back on that little base piece to black. Now I'll take that one out, that was our orange one. This was the one that was black. If I put that in as a black, on the one I just changed to orange, it'll flip to orange. So it's nothing inside these, there's just a fixed magnet in these. That basically proves beyond any doubt. And again, if I take that one out and put this one back, oh, actually I've got to put it upside down, I guess, back on black. This one, this segment will go orange in this unit. But if I put it back on one of these ones, orange facing up like it was there, it goes black and will not go orange. And so if I put it on this side, it's black and won't stay on orange. So it's these little former bits that determine what it is, and once you flip them, they basically hold there. If I completely disconnect that from power, it still always goes to the orange state. I forgot which colour wire that was, I think it was the blue one, flipped it orange. Yeah, so if I go white, it's now black. And if I get one of these other segments and put it in there, they stay on. Oh, that one's making a liar out of me, it jammed for some reason, but yeah, they go to black. So it's this little former piece, this little pin in the middle, that's what actually determines which way they go. I guess I can undo it again and have a look. Not that you can see much, it's just a metal pin. There's a little washer on there and a nut. Washer doesn't want to come off, so that's the pin. It's just plain metal pin with threaded bit on the end. If we put it near these, it'll actually pick that up. If I go to the black, it flips it over, and it can just, it's not very strong, but it will pick up the orange, and it will repel the black. Roll that out of the way. Yeah, so interestingly now, see that moves away from my screwdriver, whatever my screwdriver's magnetised to, it'll pick that end up, but it repels the other end basically. Oh, it's picking it up now, it's made a liar of me. It's interesting. Before it actually repelled it, so maybe it's losing its magnetism now. And it's still, oh yeah, it's a bit undecided now. I think I've wrecked it. Yeah, it doesn't actually want to pick up the, so there you go. So that my screwdriver is actually affecting whatever magnetic field you put in this thing. It seems to pick it up and stay that way. So it looks like I've actually weakened its magnetism. But yeah, I'm not sure what sort of metal that actually is. It's obviously magnetic. Some sort of iron-based material. But yeah, I didn't realise you could actually get a metal that would hold its, would be easily magnetised and then hold its magnetism basically permanently until you... I can't get that nut back on until you do it again, until you repolarize it. So I think most commercial sort of magnets are heated up or something and some way treated so that the metal, once the little poles are set in them, they're very hard to flip again. I think heat will just put them into disarray. If you heat them up too much, they'll just lose all magnetic order and alignment. But I think they are quite hard to change over again to a different polarity. Flip the poles on them basically, but it's probably possible. But yeah, let's see what it does now, if it fancies one way or the other now that I've messed around with it. Ah, look at that, I've unpolarized it. So that's so literally that's what you'd expect if it would lose, if there's no magnetic. I would have thought this metal without any power applied, because I've only got the negative hooked up at the moment, would. So I actually unpolarized this and I've completely killed its magnetic field and sent it into some sort of chaotic state. It's just like a piece of iron now, I guess. So if I re-energize that one way or the other, yep, we've gone back to orange. So if I flip it, it's now strongly black, or it's attracting the orange, pulling it down, revealing the black to be seen. And now I can flip it back and forwards, back to orange up. That's obviously attracting the black down and repelling the orange. And you can spin this thing round, but it always ends up in a particular state. So it's some sort of metal that's easily magnetized by just a fairly small electromagnetic field, I guess. And once you set it, it stays in that state. And it's obviously enough to affect a fairly small magnet. Obviously there's not much pivoting resistance on these segments. They're only little things. Not much mass to move, and the pivot's nice and easy to rotate. So it's just a minimal bit of magnetism in these things. And yeah, like I say, they hold whatever was last put into them. I don't know how long, but it seems to, I would assume this display hasn't been used for a while. For what these were used in, because they don't seem to be used in petrol Bowsers or anything. They're quite a big display. They're about the right size for something like a petrol Bowser, but I couldn't find any info on this type of display at all, let alone any equipment that actually used it. But so we can happily flip away between one state and another. I can't really do the other segments because they're still wired in. I just cut the wires off the board on this one. But it would be interesting to actually try and power this thing up and maybe work out a little schematic, though I couldn't find any data on these MB434 chips. It'd probably be possible to somewhat work out what's going on in there. Very few pins actually used, I think. Let's see, that's, oops, there goes the segment. Positive pin 16, I think that's negative. Yeah, that's the negative, the capacitor. So I've got all this negative trace. That's one corner of the chip, the one with this big track here. We've got two pins joined together. A pin that probably doesn't go anywhere. Another pin that, oh yeah, that pin is connected to something. And yeah, if that's power, the opposite corner may well be ground. Power on that corner. Oh yeah, there's a bunch of, I wonder if that is ground. Yeah, joined. Yeah, so we've got ground, 5 volts. That's got rid of 2 of 8 pins. We've got 2 pins joined together, so it gets rid of another 2, I guess. And one that possibly isn't used. It's always hard to tell with double-sided boards, and the other one is used and goes in this other chip. So yeah, not sure if they've got NAND gates, maybe. I don't know how you'd split the signal up to. Like I say, you have to basically pulse this once. So depending whether you go negative or positive on the common one, well, they've got to get a positive pulse to get it to light up as such, to go orange, and then a different negative pulse to make it black again. Or depending how you wire it up, you need positive pulses to do that. But with a normal LED, you just have a pulse. You know, normally a high voltage, whatever volts it's made to run on, just a high out of the chip, 5 volts or whatever the rail is, and that turns your LED on. You put a positive voltage into it and the other side on ground, and when you take that signal away and go back to 0, the LED goes off. So yeah, not exactly sure how they do that. I guess I could try and fiddle around with this a bit more, but I think for the time being that'll probably do. It's a interesting little novelty, and yeah, I haven't seen anything like this. I'll try hooking up. If I hook the positive up to the center tap, it'll just should change the direction. So the blue went to black. If we put negative on there, blue should go to orange, which it does. White goes to black. Whoops. Positive on the center tap, and blue goes, well, keeps it in black because I'm already on black. White is orange, blue is black. So you can, I guess, set this up either way that suits, but yeah, you do need 2 pulses. It needs a set and a reset pulse of the same polarity. Unless you wanted to get really technical and swap the center tap to a different voltages or something, but pretty unlikely they do that. But yeah, quite an interesting unit. I don't know if that's got anything to do with the model number, C61L0120-0002. That could be something to do with the model number. It might be on there rather than on the circuit board. But yeah, I couldn't find any info on the internet on this, and like I said, I did put it in a Facebook group on the test equipment sites and asked if anyone had seen it and anything, and people had some ideas about it, but not a lot of info on it. I couldn't even find any like Fujitsu catalogues or anything, old ones online or anything. So a lot of this stuff that predates the internet, or even, you know, around 2005 or something, a lot of the stuff from electronics from before that, there's just very little info on it. If you're really lucky, you can find maybe an old catalogue on archive.org or something like that. But a lot of this gear that was around back when I was working on this stuff for a living, there's just absolutely zero information on the internet about it, because it's all predates that era. But yeah, it's quite an interesting little device. If anyone has any info on it, let me know in the comments, but I thought it'd be worth a look just as something different. Yeah, we're all used to the LCD and LED, and even the, oh, that's popped out now, so I've broken that. Just needs popping back in. I don't think I can get that back in easily. It doesn't have to have one on orange anyway. Probably should have left one of them on orange. But yeah, if anyone has any info on it, let me know. And yeah, a lot of the other displays you see still around commonly. I do have an early Lixie display in a piece of old test gear, which I must do a video on one day. That's basically got the light bulbs go through. I think, yeah, they're edge lit, little etched perspex little panels, I guess they are. Thin perspex, and I think they've got somehow they've etched or drilled or something into it to put some sort of texture into the plastic, and when you edge light them, wherever it's textured, that bit lights up. It looks almost identical to a Nixie tube, except that you can see the front of it's flat, even through the front panel. And then, yeah, when I opened it up, it's actually got separate little incandescent globes that run each segment. A lot easier to run than something like this. Nixie tubes, I was looking at some old TV circuits, and there was actually a German TV that had a, I think I may have seen it once, but it had a Nixie tube as a channel indicator, whereas most of them had 10 separate neons. And I thought, oh well, that's interesting, you'd have to add some extra circuitry to get the 7-segment type display, but of course with a Nixie tube it's exactly the same as just having 10 discrete neon tubes. It's just you hook up the 10 separate segments to where the neons would have gone, so there's no need for decoders. Like your normal 7-segment type decoder, because obviously with 7-segment you know, to get a 1 you've got to get 2 particular segments up, to get a 4 you've got to get a different arrangement, so it's not as simple as just one line can light up the ones you want. And with this one it's even more complicated, because you've got like a set and reset. You've got to set the segment to on to the orange, and then going to reset it back to black. So that's a little bit more complicated. It's not just a matter of applying a voltage and it flips orange, and then you remove the voltage and it goes back to black, which happens with an LED. You apply voltage, it lights up. You remove the voltage, it goes out. Much simpler system really, probably why this sort of thing didn't take off. I would assume this was quite expensive to manufacture generally, just besides all the electronics. The mechanical stuff, the coils and all that sort of thing, copper wire, all that costs a lot more than, and all this assembly, a lot more than with LED displays, but these do have some advantages, like you can set and forget. Obviously a lot bigger than the LED displays probably were back then. They may have had some larger ones, but a lot of them were just the tiny little, I forget what they are, maybe ½ an inch or something if you're lucky. So yeah, this might have been for special uses pretty good back in the day, but I think the Nixie tubes or even the odometer type ones were more the thing back then. But been an interesting little thing to look at. It would have been a shame just to see it get destroyed for e-waste or something without actually recording that it existed. But there may be thousands of them out there somewhere, I don't know, but I've certainly never seen one. Maybe they were used in some sort of industrial application. There were certainly a few old industrial places around where I live. Back in the day, a lot of them are shut now. There's still a couple of larger places, but they, for their instrumentation or production line stuff, they'd have all sorts of interesting stuff, and money wasn't a problem for them, so they'd buy a lot of this high-end, expensive stuff that was well out of the range of the consumer. But yeah, I'd say it would have, given just the price of it alone, would have been an industrial or commercial type device. But yeah, there you go. That's been something a bit different, and yeah, just another one to add to the range of rather weird displays that have been made over the years. And yeah, a lot of them disappeared now. Everything's obviously on an LCD panel or something now, colour and backlit and the works. Not like the old days of having to fiddle around with this sort of gear. A lot more complicated. Now you just program some software and feed it to a universal kind of display. So this is definitely one for the history books, I think. But thanks for watching.